Yeah, let's get. Oh, wow, that's hard. Hi, let's get started. I see my slides are a little bit off pace, but don't let that interfere. Welcome to my talk about security. And I think it's a good thing to see so many of you at least a tiny bit interested in security. Or you want to just see me fail, that's also a nice thing to see. Today we're going to talk about DevSecOps. And who likes the word DevSecOps? That's nobody. And I completely agree with you. I hate the word DevSecOps. But let me get into the first one. Who likes the word DevOps? One. Yeah, I like it too. I mean, it's kind of cool. Like we had developers and operations, let's tear down walls, put it together in one team because we're responsible for the whole shebang and not just for our only silo. And we abbreviate that with that kind of cool name, DevOps. And now there is this thing we call security, and it's so important, let's put it in the middle. That's how DevSecOps sound to me. Like my grandfather who wants to talk slang to his grandchildren, and the children are like, no, dude, don't do that. But the point is, the sec is in the middle because it is important. But again, what's next? Dev, cloud, ops, performance, scalability, whatever. I don't like the word, but let's get into the middle. Let's get into that security part. Because security is everywhere. And we have to deal with it as developers, right? Who of you does DevOps? Who of you practice DevOps? A few. Okay, let me rephrase that. Who of you creates a program, need to deploy it into production, hopefully automated, and when something terribly goes wrong, you will be called with the question, can you fix this? Who does that? My friends, you all do DevOps because you're responsible for the stuff you build. That is DevOps in general. And not like, yeah, we have this operations guy in our team, he does everything. No, finally, you have to solve it as a developer. Who of you is a developer here? So I've got the right audience. The rest of you are managers, hopefully. Listen carefully. But first, who am I? My name is Brian, and I work for a company called Sneak. Funny little dog. We create security content and security tooling. And we have our own security analysts as well. But what we want to do is to engage developers to adopt security. So we build tooling to make it easier. I do a lot of stuff for the community, like do some work for the Utrecht Jug. I'm co-lead of the Secure Developer, which is an online community for secure development. Anybody heard of the VJug, the virtual jug? One, you should check it out, because that's the only jug that you can just see the talks from out of your chair without going to the venue, without even getting clothes on, which is pretty convenient. If I host the stuff, I do wear a shirt. No worries. So, but we're going to go into that DevSecOps thing, right? But first of all, okay, security is a thing, but what is the problem we're trying to solve? Is there actually a problem? Well, say 5 to 10 years ago, when I was full-time developing as a contractor, I was working for a government agency. And the point was, we went to production 3 times a year, which was okay for that time. But nowadays, we want to speed up these things. And one of the last projects I worked in was for an e-commerce platform. And they actually sometimes deployed 3 times a day. So the point is, we want to speed up things because we want to be faster, better, stronger, and we need to be earlier out than our competitor, right? That's what we're trying to do, getting the features out as soon as they're shippable. But in many cases, we have this product owner or this product manager who is harassing you basically with the question, when does this come out? I want this feature yesterday. So we're trying to do our best and make it possible and build stuff. And that's cool. But most of the time, our focus is not on security. And that's a problem. And if we speed that up, then we have a problem with that there's a lack of security focus during the whole life cycle. Because we think about performance, we think about scalability, but security is not on a developer's mind. Because we're builders, not security people. And what you see in most companies, you see, although we try to tear down walls and have that DevOps thought, at the end there's that security team who basically say no. Because I want to get out with this feature, they test it and they say no. And you end up with some kind of war within that office. I don't like these guys, these guys don't like me. But in the end, we do need to take care of our customer data. So, all right, that's all fun, but how bad is it? Who of you have ever heard of a company called Equifax? They were kind of in the news, like 2 years ago. Equifax is a crediting company in the US, and they used an outdated library of Apache struts. Long story short, they didn't know. They got hacked, or they got breached, and 143 million records were out in the public. So after this, everybody knew Equifax, which you could say it's good marketing. I mean, they know your name at least. You do not have to do anything about that. But is that what you want? I mean, the fun thing is, attackers were in that system for weeks, and they were just snooping around easily. And when they found a little bit of stuff that they could use, and they go back and they try to dig deeper and deeper and deeper, and eventually they found out that they could get into customer data. So let me just show you that hack. I think that's funny. Let me just, now you see a copy of my screen. All right, so I have an application over here, and as you probably can see, it works on Heroku. It's in the cloud. It's a cloud instance of a very simple application. I will get into the application later, but just make sure that you see it's not on my local machine. Well, what will a hacker do? Go to the browser, puts his hood on, and try to do his best, right? Because without the hood on, you're not a proper hacker, they say. Well, the Apache struts thing was a difficult one. But when you know how to do it, it's not that difficult anymore. I will show you the header we need to use. And I will enlarge it for you so you can actually read it. What is the point here? With Apache struts, we could send data up and down. And what we could do, we could call a URL with a certain content type. You see it over here. What I'm trying to do is to manipulate the content type. Who recognizes this content type? Nobody, right? It's an illegal content type. So what happens is it goes into an exception flow. But Apache struts has this OGNL language, the Object Graph Navigational Language, the local or DSL for Apache struts. And you can use that to set properties from different objects, create new properties, and that's exactly what we do here. We create new objects with that OGNL language. Because it goes into that exceptional flow, there was a flaw in it that you could use the OGNL language to create a new object at runtime. And what we do over here is that you can see that we want to insert a command. And we do that with a new Java processor builder. And what we do is we call the bash with a command we insert. What does it mean? We could execute arbitrary code. So, how does that look? What does that look like? Exploits. Let's go to that exploit because I'm not that smart that I know all of this by heart. So what I'm going to do here, I'm using this one. What I do here is I'm using that header I just showed you, and I substitute that command with simply the env command, which shows you your environment variables. And I'm just calling, let's not call that local system. Let's call that Heroku instance that we just had. So I will just call that Heroku thing, and execute it. And what we see is we're just using this struts library. We didn't do anything wrong, we think. But it was vulnerable. And with this header, it was strange. But now I can see the environment variables of my Heroku instance, which is fun because now I know which Java ops to use, where the Java home is, Java home is /app/.jdk. Keep that one in mind, just for later on. We're going to use that one. So what you see is by using the wrong library, you didn't probably know about it, but people just can't get in. And if somebody found out that header and published it, what happens? People will misuse it, and people will use it on your machine, your machine, your machine, your machine, or try to attack all kinds of systems. And if it works, it works. They will dig in deeper. And that's what happened with Apache, or with Equifax. So getting back to my slides, hopefully. So say this is your application. This is your application that you put into production. How much of the code you put in production is actually your code? Probably this, right? Because we depend heavily on frameworks, on libraries, on all that kind of stuff. Because we do not want to care about boilerplate. I don't care about creating yet another REST endpoint. I don't want to be bothered with creating another CRUD repository to access my database. If there's a framework that can do that for me, that's cool, because now I can focus on business logic. And that will make the difference for my company. Because we want to get better, faster, stronger, and earlier, which is good. But let me get into a few examples. I have a serverless example over here. It's Node, and it's easy to make fun of Node. Who's a Node developer? Oh, poor you. But it's 19 lines of code. Okay. It has 2 dependencies. How much dependencies does it have in reality? Because the first one is AWS SDK. How much dependencies do I pull into my system? 19. It is Node, but this one is not that bad. It don't download the whole world, just part of it. But the fun question is, that 19 lines of code, how many lines of code will there actually be packaged into that binary and go into production? How many lines of code? Guess, scream. What do you think? 1,000 or 100? 500,000? Yeah, I know Node is bad, but it's not that bad. I said it was easy to make fun of Node, but no. It's almost 200,000 lines of code. 19 lines of code, serverless application. We're using the AWS SDK, creates a whole bunch of stuff we don't know, and we just use. How many of you people use code reviews? Who does code review? The rest who doesn't put their hand up, they probably do pair programming. Let's not get into we don't do anything. But basically what you say is do we trust our peers? Not blindly, because we can make mistakes. So we try to review the code at least so we can get these mistakes out. How do you do that with libraries? You just put it in production, and if it works, ship it, and continue. Next example. This one is a Java one. It's fun. It's a Java example, and it's 222 lines of code. Because a lot of replication, we created this as a demo. It has 5 dependencies, which will result in 54 dependencies in total. It's a Spring application. So, guess, how many lines of code will I put into production? Spring does a lot of magic. How many lines of code? Hoeveel? How many? 2 million. Not that bad. It's Spring. Almost 500,000. 460,000 and 64 lines of code at that time. So we depend on these packages. And that's cool. And open source usage has been exploded, which is good, I think. I love open source. We need to use it more, and we need to make it stronger. But open source is not particularly safe, nor is it unsafe. Don't get me wrong. But you have to use it with the same passion and in the same way as you use your own code. And if a problem is there in an open source package, the point is, if so many people are using it, I'm just having a really big gun and fire at everybody because, well, everybody's using Spring Boot or Quarkus or whatever, right? So if there's a problem in there, there are many possible victims. One vulnerability, many victims. So if you look at the state of open source security, which was a report that was released in February or March this year, and we look at the total packages that were indexed on each ecosystem, you see that NPM by far is the winner. And that says something about the quality, in my opinion. I mean, this growth, there are over 1 million packages at this point. Well, a few months ago already. But still, if we look at Maven Central, the blue line, it's still a growth of approximately 100,000 packages in 1 year, which is massive, in my opinion. If you look at the number of vulnerabilities that will be disclosed this year, unfortunately, Maven Central, or Maven, we, the Java people, are the clear winners. Is that something to be proud of? I don't think so, but it's something to take into account. And if we look at these problems, these dependencies of problems, it's not the top-level dependencies in most cases. Just look at the third bar and the last bar, Maven Central and NPM. These are the biggest ecosystems. It's not the top-level dependency that is the problem. It is what's underneath there, because a dependency uses a dependency using a dependency, and there deep down below, there can be a tiny problem in a commons library, whatever. But by introducing this in this big package, you're vulnerable as well. Well, now we ask maintainers how confident they are. 63% says kinda, but we do not trust our peers. And who is responsible for security? We ask the same people. And they say it's a shared responsibility between developers. 81% say developers have at least some sort of responsibility to take care of if we look into security. Most of the time, it is developers together with the security team, together with operations. But as developers, we need to have our fair share to take a look at that. Well, we get into more details like how do I find a vulnerability, but this one is a nice thing to say. So, a package is out. How much time in general does it take if a vulnerability is found? How much time does it in general take until it gets fixed? Because most open source maintainers are willing to fix things quickly if they see there's a problem. Any idea? 2 hours, that's very quick. But the mean in this case, or the median in this case, is 16 days. That depends if the library is short, is it a small library, is it a big library, and depends who's maintaining it. If it's, for instance, if it's a Spring library, then there are a bunch of developers working on it. If it's Red Hat who is maintaining it, there are people dedicated working on that. But if it's a library that is not maintained by a vendor, then it can be. And this is over multiple ecosystems, not particularly Java. But say, who has an application out in the open which been there for years, like a legacy application, and you still need to maintain it, but you do not dare to touch it? I had for years. Everybody here works on greenfield applications. Good for you. No, but if you have an application, a vulnerable or a web application out in the open, it can be that the point where you deployed it, it was perfectly fine, perfectly okay. But yeah, people dig, people try things, and then a vulnerability is found. It can take up to 2.5 years before a vulnerability is found. So that means if you have an ancient application because you work for a bank, and it needs to be there, it's in Java 1.2 or something, and whatever, it probably is vulnerable. So you have to take a look at that, and just not touching it, because if it works, let's not touch it, is probably the wrong strategical thing to do. Who uses Docker? Who builds their images on top of images from Docker Hub? We took a look at the top 10 downloaded images that were free, and how many vulnerabilities there were. Node is the clear winner. Yay. But the point here is it's not problem of NPM or Node in this case. Why? The image, if you just pull the last image, well, this was done in March this year. If you pull the last image from Node and you looked at that image, it was built on top of an older Debian Jessie version. So you do not only get the problems from Node, but you also get the problems from your operating system. In this case, all the 560 whatever things were not node related, were all related to the operating system layer. And if you just blindly use that and put it in production, because, well, it's from Docker Hub, you can trust it, right? Well, we can get further and further in these kind of questions, but let's get into that hacking part. I already showed you one thing, but let's show you a few other things. First of all, I'm going to quit this one, and I will... Oh, no, you were good, like there. I already said it's quite easy to make fun of Node. And we have a Node.js application over here. And it's a to-do application, so I can do something like buy flowers. And it puts it into my to-do list. Not very, very nifty, but it's an application that is out there. It also has an awesome about page. You see, it's the best to-do app ever. Anyway, we're going to hack this one, because I know this application is using a Node library called ST. And ST stands for statics. So it will serve as static content like the about page. And I know there is a path traversal problem in it. So I want to do a path traversal. Any idea how to start? No hackers in the room? Well, first of all, putting my hood on and going to the terminal. That was the first thing. So, I'm here. Say I want to do a curl thing to localhost 3001. Cool. But now I do it to public/about.html. Let me just enlarge that one, or let me just put that on top. And you see I have my about page. Make it a bit larger. Nothing special. So I want to do path traversal. And why do I use curl? Because the browser optimized things for me. And with curl, I can send direct commands. That's basically why I use it. I don't want my browser to interfere. So path traversal normally is something like .. // right? So let's try that. .. // And I can do that an infinite amount, because if I'm in the root and I do .. // I will end up in the root. Unfortunately, that doesn't work. If you see, I will get back to my to-do main page, because the ST library is a real library, and it scans for that .. // But it whitelists, or it blacklists the .. // instead of whitelist. So what can we do? Say we cannot use the .. // Maybe we are smarter than that. Any ideas? .. // And then .. / like this? Sorry. That's the first one. That's the first time that I heard that. I love that. Well, some people say let's try to escape it like this or something. Well, I can tell you that doesn't work either. But what does work? Sorry? Almost. I will get to the answer. URL encoding is the answer. Who knows the encoding for a dot? I'm so glad nobody knows that. Last time I did that, I was like, so let's use URL encoding, and somebody put up his hands. Yes, sir? %2e. What? %2e, that's the encoding for a dot. I'm like, okay, are you a hacker or are you a programmer? I don't want to know. Let's keep that there. But it's %2e. So %2e is a dot, and again, %2e is a dot. So let's use that. Let's copy that one. Oh, that doesn't work. Normally I can copy and paste in my... Yes. I don't know why it doesn't work. Wait a minute. I think it has something to do with how my screen operates at this point. So now I can do. So like this, and you see I'm in the root of my system. And of course, every smartass would say, you shouldn't be running your application as root. Yes, that is true. But think of yourself, how do you run your Docker applications? Probably as root. And if not, good for you. So what can we do now? Let's get a look into the passwd file of my system. And we have that all in the open. And again, this is not a harmful thing, because people can only read, right? We cannot change anything. So this is classified as a low or medium severity. But the point is, I can read, so I can snoop around, and I can see if I can get into files that may contain passwords or connections to libraries. And I can use this as my starting point to get on and on and on and on. For instance, and it's probably not considered getting out of the sandbox of public, but if I do this, let's remove all the %2es. If I do this, I see that I have the package.json over here. So I can look into the package.json file and see which dependencies you have more. Hey, that's fun. Let's put that to the CVE database and see if there's more vulnerabilities. So it is a starting point. Okay. This wasn't that special, right? Let's get into this application. And let's get into a new one. For instance, who likes regular expressions? Okay, for those, keep your hand up, keep your hand up. Who likes to read and debug other people's regular expressions? No, 1, 2. You like that? Wow, I hope you have enough free time on your hands in that case. Regular expressions in many cases is like a write-only thing. It can do super fast pattern matching, but it's not the thing I want to read. If I write it and it works, ship it. That's kind of. But if, say, we have a regular expression, and the regular expression is a very silly one like this. Where is my plus sign? Plus, star. And I try to match it towards a string like this. It matches, of course, right? Because it works. It's compatible. But how do we know how that regular expression operates? Does it use the plus? Does it use the star? Does it use the star until halfway and then the plus? Basically, we do not know because, well, it's deep down below implemented, and it simply works. But what we do know on regular expressions is, if the regular expression is very long, and we try to match it against the pattern, and it doesn't match, then we go into some sort of backtracking mode, right? And basically, we can, what a regular expression does is we try that pattern and try to basically do every single line or string that it can compile from that pattern and match it to that string that you want to compare with it. So it goes into backtracking mode. And that's a fun thing. Because if the input is very, 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 very large, it will go into backtracking mode, and backtracking mode, and backtrack and tries every single possibility. On how many threads does a node application work? There can be only one. One thread to rule them all. But yet, if I occupy that thread with the computation power it needs for that regular expression, it is stuck. So you have a denial of service, temporary, until all the possibilities are there. So let's get into that one. I think that's fun. We call this a regular expression denial of service. What I first do, I'm going to show you an example. It's called, we're trying to fill in the form. We'll use this example. And it uses HTTPI, or HTTPI, I have to pronounce it like that. It's a HTTP client on my local machine on that can handle command line. So what I try to do here is I try to insert callmom in 20 minutes in my form over here. And that works. So what we see now is that if I refresh this, that it does something with that 20 and minutes and comes back to that 20M. So it does something with times. Fine. Let's get to the next one. So I will do basically the same one, but kind of differently. I will put 60,000 fives, let's match it to minutes, and put it in the form. Oh, damn, that works. And pretty fast as well. And what does it do? Buy milk in infinity days. Probably by then it's sour, but fair enough, it can. So what we need to do is, it's quite big, it's quite large. How do I make sure that it goes into backtracking mode? Well, I am Dutch, and I work with English colleagues. The problem is I misspell a lot, because, well, it natively sounds good, but, well. So let's keep it to that. I misspell a few things like this, because it sounds awesome. Instead of minutes, take it minutes with a Z. And now you see it hangs. And if I go back to my application and I bash my enter button, it doesn't work, because it's in that backtracking mode until all the possible options were done, and then it sees it doesn't fit, and then it leaves the thread hang, and then it comes back. And now the rest of my requests will be issued. The point is, who of you works on the cloud? Let's say if you work on the cloud, it will probably not be a denial of service. But because I just occupy one thread, and that instance is occupied, so it probably spins up another one, and 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 then we got a denial of pocket money instead of a denial of service. But guess what? This is quite dangerous. Say you are the main competitor of Amazon, and Amazon has this problem, and it's almost Black Friday. Let's make sure Amazon is not available, because at that point, people will come to you. So you basically have an advantage in there. So these kind of things, denial of service, you cannot change anything, but by occupying somebody's space, it can cost you your revenue for that particular year because, well, Black Friday probably is the best sales day in every single year. All right. I mean, it's easy to make fun of Node, but let's go into Java, because Java has a lot of problems as well, depending on which dependency you use. So let's go into this this application I just showed you. It is that thing on Heroku, and let's sign in. Oh no, let's sign up. I created a new instance. So let's sign up, and I will use my email address and my name, and I will use a password 123456 because I work in a security company, and this is a very secure password. No, don't save it. So again, this is a to-do list because I didn't have any inspiration. Sorry for that. What I can do is I can create a to-do. Again, buy flowers for my wife, because I'm away a lot. Let's put it somewhere 90, 70, and give it a high priority. You see, that works. Well, I already showed you that this problem, there's a problem with Apache struts, and that was in this application. And I asked you to remember one thing, and what was that? Sorry? The Java home. The Java home was /app.jdk. Okay. There's another thing going on here, because we can upload files. And what we can upload here is zip files. And it unzips a zip file using a library, and then puts the stuff into a certain folder I wish to do. Okay. Say I have a zip file. I have it over here, and we call it the zip slip. And let's look at that zip file. This zip file has two files. One good.txt and one ////////app/.jdk /bin/native to ASCII, which is basically the native to ASCII code that is part of your JDK. What we're trying to do here is break out of that sandbox, do the path traversal to the root, go into the JDK, and override the native to ASCII. Because if I'm here and I create a to-do called eat pie, and again, I set it to 1970, and I'm quite hungry right now, you see that every single label or every single title goes to that native to ASCII mode, and you see that that pie character is changed into an ASCII representation. So I know that native to ASCII is used. It's not that hard to figure that out. So what I'm trying to do the native to override the native to ASCII function. Let's try that. So I'm going to upload a file. I will choose that zip file I would had there. No, not going into the scanners. Let's see where it is. It is in demo. It is Nick Java Goof exploits. Zip-slit.zip. I open it and I upload it. And what you see is that in the public folder where I expect my stuff to be, there is that good.txt. So it can mean two things. Either it ignored the .. but in that case, I expect it to have an error message somewhere, or a message like, this zip file is illegal, or it executed it. Well, guess what? And I just put in something, because it doesn't matter. Every label goes to the native to ASCII file. And I overwritten that stuff with muhaha gotcha. It's simply an echo. I can show you the native to ASCII. It's echo muhaha gotcha, and I can put anything in it. And why I wanted to show this is because it runs on the internet. So it's not something I prepared on my local machine and tried to figure out like, oh wow, this is so interesting. The problem is that this library I use, it was the ZT zip library that can unzip. But the problem in Java is we do not have native libraries to unzip or zip. We do have the building blocks to do it ourselves, but we need to recreate it ourselves. So people thought, okay, let's make a library out of that. But if you do not care about the path, and you just blindly take the path, take the file name, put them together, and execute that, then you end up with this problem. You can solve this in Java if you write your own by using the canonical path, and then match if it's the same. Because that .. the path traversal, the canonical path, will give you the final path that, where the actual path, where it goes to. And if it's not the same, you probably see that people are trying to do something weird with it, and you can ignore it. By uploading the same, by using the same library but a version higher, 1.13, they solve this and you will not have the problem. But to be honest, if you write JUnit tests, are you looking for this? I would not. Somebody has to tell you, right? I wasn't even aware that you could create zip files with .. in it as a file name, but it's possible. So these things look very, well, unexpected, and people say, yeah, how do you come up with that? But the point is, if somebody came up with that, publishes it, then you're done. How many times I got? I got about 11 minutes. Well, let me get you to one Java one, which is a, oh no, this is Eclipse. Who uses Eclipse? Let's go into this application. And this application is a Spring Boot application. Already runs. And what you see over here is, let me just enlarge this one, is that we have a grocery list. All the items are not so important, but because we are using Spring, and it's just a name and a cost. The interesting thing is the repository. Because the repository with Spring we can just extend the CRUD repository, and it gives you CRUD repository functions, which is nice. I don't want to be bothered with that. So I can do all sorts of things without implementing the actual SQL stuff. But the funny thing is, by using this annotation, the repository REST resource, it will transform my CRUD repo into a REST endpoint. which can be convenient because we want to build fast. Well, you already get this. There's a problem with that. Application already runs. Let me make that a little bit smaller. So if I go to items, you will see that all my whole grocery list is here. Right? If I go to items /1, it will give me my first item, which was beans. I can also use things to find stuff, like find by name, and my name is beer, cool, and it will only return beer. So my CRUD repo is now also a REST endpoint. Fun. Let's continue. The point only is we do not only have getters or get endpoints. It also publishes some more. And what we will use now is a curl message, which, let me see where it is, over here, where we insert some extra JSON. We insert this JSON. And again, it looks like JSON, but underneath we are looking at Spring Expression Language, SPL. And with a Spring Expression Language, just the same as with the struts library, because who uses struts nowadays? We're using Spring Boot. What we try to do, we try to get to runtime and execute a command. Give that to an input stream, connect that to an output stream, and give it back. So basically, I can execute again any arbitrary command. So I can do the same over here by doing the exploit, and let us do the end is the easy one. I don't have that much time. So by using this command, you will see I will use just a curl command, a curl patch command. I'll give it the content type JSON, and I will use that JSON with that endpoint that was used just to get my first item out. It's just the arbitrary endpoint, which normally doesn't do anything. But because it's a patch command and I can insert this stuff, and I'm asking for the environment variables, by running this, I will have the environment variables of my local machine. And again, I can use any Linux command I want. So I can override, for instance, the ls command. Come back 2 days later, execute the ls command. And even if you have proper logging, good luck finding out what happened. So this is vulnerable. Okay, all the vulnerabilities are fun, but how do I solve this? How am I going to work with this? Well, the problem is not easy to solve. Solution is 3 parts, and they're equally important. Team culture, process, and tooling. Well, tooling is obvious, but let's get into the team culture. Because we work with different people, developers, security people, operations, management, and we all think about different things. Developers want to build stuff, right? Want to ship stuff. Security people don't care if it works or not, because if it doesn't work, it doesn't go into production, you're not vulnerable. Easy as that. Operations, classic operations, they care if they wake me up at 3 a.m. to fix things, if I just can hit a button, if I can push it on and off and it works again, I'm good. And management, they care about profit most of the time. But we have to align that. So if we as developers need to work with the security team, why not implement this from the beginning? Why not use this mindset from the start so that not at the end, the chance that people say no is slimmer? But then you got process. People want to throw in process because if you ask people, do we want change? Everybody raises their hands. But if you ask the same people, do you want to change? Nah, not so much. If I ask you, you have to pen test every single release you do. You probably do that if you got breached yesterday and you say, okay, fair enough, let's do that. And you do that for 2 weeks, and then your operations manager comes again, and he wants to push you again to go harder, faster, stronger, and you leave that back and you will return to your old process. So if we can create this process without interfering your stuff, that you can still keep your eye on development and automate as much as possible, that will be fine, because you probably run unit tests before you push your stuff to your master branch, right? Hopefully. Or automate things in a CI pipeline. There's where tooling come in. You need to have the right tooling that helps your process. There is no one silver bullet that fixes all the security problems. There is none. We do have some tooling, but that's just partial. And we need to automate as much as possible. If I have to do it manually, I will do it twice and then I will leave it because it is too much of a hassle. So what we say is create a secure pipeline. And that pipeline is not your CI pipeline, but the pipeline from development on the left, your repo, your CI/CD, and production. And if you start as left as possible, so from your local machine, if you can test and fix over there, I bring in a new dependency. Can I fix it? Bob the builder would say, yes, we can. If you have the right tooling to scan it. Say you want to put it into your repository. Why not scan your repository on a daily basis? Why not, if there is a new version out and it fixes that particular problem, why not automate that you have a fixed PR? Not put it in, but that the pull request is already there. That saves you a lot of time. And for one problem, it's just one thing. But if it constantly, because people constantly look at vulnerabilities, then in your CI/CD pipeline, you still need that gatekeeper. But if you have all the things before that, for instance, every new branch that comes in, every pull request that somebody pushes, if we can look at the delta and see if there are problems, you do not bring new vulnerabilities in. Then your CI/CD pipeline, before you go to production, of course you need a gatekeeper. But you're not done when you're in production. You need to keep scanning that snapshot, because it can be vulnerable tomorrow. So, for instance, use things like plugins for your IDE. I have a plugin over here for Eclipse that gives me an overview at the point, okay, I have a vulnerability in here, but it's not the top level, it's the third level down. And, well, for this there is no solution, but for the other one, there is a probable solution. And if I can do this from my local machine, then I will prevent committing new code or committing problems. We have the same for IntelliJ. If I do it over here and I see the plugin over here, for instance, here we're using a Spring Boot starter web 155. If you upgrade to 159, that actionable result, that is interesting, because now I know how to fix it and go. Connecting your repo to a scanner and say like, oh, we have a problem here, fix this vulnerability, or at least give me the point there where what I can fix. Of course, I show my own tool now, but there are multiple tools to do this. And this is only partial, because you also have to take care of your own code. So static code analysis. There are a lot of static code analysis that are there. There probably will be false positives and false negatives, but you have to take care of that. So take care of that from left to right. From the point that you develop on your local machine to the point that something is in production. Take a snapshot, scan that stuff on a daily basis or weekly basis, and prioritize the problems you have, because sometimes it's not of your interest. But move it not only in your CI/CD pipeline, but move it as left as possible. That's why we say shift security left. And I want to end with that statement. If you want to know more about that small purple dot, which is your code, we just created some cheat sheets for both Java and NPM, how to get your code, how to get code reviews and how to code securely, because that's also important. I know now focused on vulnerabilities in your dependencies. But coding securely and how to look at that is important as well. So maybe this can, and some of these things look pretty silly. But if you do code reviews, look at these things as well. Not only performance things, not only scalability, but also things like security. My name is Brian. I work for a company called Sneak. We run the secure developer community, or I run it as a co-lead. If you have more interest in AppSec in general, for many ecosystems, just apply or just join them, and we have online meetups, so you just can see them live, or afterwards, and maybe it's interesting to you. From cloud apps to apps on your local machine, everything comes by from different professionals. Thank you so much for attending. If you have any questions, my time is literally done now.